Guys, and welcome back to Matthew Wister. I'm going to be covering very quickly trig ratios because look, I had been working on a video for like 3 hours or more and I stumbled across a technical difficulty and now I can't upload it. So I'm just gonna quickly go over it here. Hopefully it's quick. And yeah, so just for an overview, right, we have our coordinate plane, and in that coordinate plane we have 4 quadrants. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in quadrant 1, right, we have both positive x and y coordinates. Then in quadrant 2, we have negative x coordinate and positive y coordinate. Quadrant 3, we have both negative x and y coordinates. Then quadrant 4, we have a positive x coordinate and negative y coordinate. And then here in our other coordinate plane, we have the 3 separate trig functions, which is sine, cosine, and tangent. So the acronym that represents this is SOGA-CHA. So what this means is that to solve for sine, right, you need the opposite over hypotenuse of a right triangle. For cosine, you need the adjacent over a hypotenuse of a right triangle. And tangent, you need the opposite over adjacent. So here in this coordinate plane, right, let's say here's your triangle. Oop, that's like really bad. Sorry guys. Boom. Right, here's your triangle. And here we have theta. Theta is just basically a variable. Here we have a right angle. So here, this line right here is our hypotenuse because it's the longest side. Then this is opposite of theta, and this is adjacent next to theta. So if we were to solve for sine, right, we would use opposite over hypotenuse. If we were to solve for cosine, it'd be adjacent over hypotenuse. And then tangent would be opposite over adjacent. So the next rule is that when you're solving for this, right, we have a unit circle. This is called a unit circle. So unit circle has a radius of 1. It does not look great, but it has a radius of 1, right? So that means that this is 1. This is our hypotenuse, right? Here's theta, here's this. Boom. So the main thing is here we're going to have something else similar to x and y, but this time it's actually going to be cos and sine. So the reason being, when we solve for cos, right, we're using the adjacent. So the adjacent is here. Remember, adjacent is here. It's horizontal to theta, right? It's horizontal. So that's why it's x, right? It's associated with the x-axis, x coordinate. Then sine, right, which is the opposite, it's vertical. It's vertical to the right angle. So that's associated with the y-axis. So if there were a question that you stumbled upon and it was asking you to solve for cos of something of like a certain point, you would essentially be solving for the x value. Now, last but not least, the last thing I want to cover is a acronym, ASTC. So what this means is, so associate these with the quadrants. So this A is associated with quadrant 1, this S is associated with quadrant 2, T with 3, and C with 4. So what this is saying is that all trig functions are positive in quadrant 1, then sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. Now, an acronym that my teacher taught me is all students talk crazy. So if that's how you want to remember it, just make it up, but find a way to memorize it. So what this means is that here, quadrant 1, all of them are positive. Sine, quadrant 2 is always positive. Tan, quadrant 3, always positive. And cos, quadrant 4, always positive. So now let's do a quick practice problem. Here's the information that we're given. So we have our circle with a radius of 10. We have a terminal side of angle theta that intercepts the circle in quadrant 2 at point C. The y coordinate of point C is 8, and it's asking us to find the value of cos of theta. So here's our circle, right? Let's draw our radius. So it tells us that quadrant 2. I just missed that. Quadrant 2 right there. So quadrant 2 is right here. Let's make our radius. So our radius in a circle is basically the hypotenuse of the triangle if it's centered at the origin. So let's say boom, let's bring this down, and boom, we have our triangle. Here's theta, and here goes 10 because that's our hypotenuse, right? So it's in the terminal side of angle theta intercepts the circle in quadrant 2. So terminal side, just like for a quick note. So let's say you have an angle, right? Just a basic angle. You start here. You start on this side. And the angle starts opening up. So it's like boom, boom, boom. Like it's moving this way. Well, sometimes. Other times it might move this way. But let's say it's moving this way, right? And you end up over here, right? This is the terminal side of the angle. It's like at the edge. Boom, that's your angle. And then it's like going this way. So it's here, right? So it's saying that the terminal side of angle theta intercepts the circle, right? So this intercepts the circle in quadrant 2 at point C. So this is our point C. And it tells us that the y-coordinate of point C is 8. So we don't know the x-coordinate, but we know that the y-coordinate is 8. And now it's asking us to figure out what's the value of cosine of theta. So if the y-coordinate is 8, right, that means that from here to here, the distance is 8, which is still along the x-axis. It's on the 0 right here. Like we can imagine it like going up, right? It's gone up 8. So that's the distance. That's the length of this side. So now we have 8 here. So we want to figure out first what's here. What's the value here? So what we can do is we can use the Pythagorean theorem, which is for right triangles. So the Pythagorean theorem is a squared plus b squared equals c squared. So a and b are for the legs of the triangle and c is for the hypotenuse. So a, which is one leg, 8 squared. For solving for this other leg, so we're going to leave it as b squared, equals c squared, which is 10, the hypotenuse. So 10 squared. So we have 64 plus b squared equals 100. Now we just solve algebraically. So we subtract 64 on both sides. We have b squared is equal to 36. And now we square root both sides, and we're left with b is equal to plus minus 6. Now here's where the quadrant 2 information is important. Remember, quadrant 2, sine is positive. Only sine is positive. But here, what are we solving for? Cosine, right? So that's different. So that means that in quadrant 2, cosine is actually negative. So we're going to take the negative value of b, and that's going to be here, negative 6. So now, let's get to the important part. We want to solve for cosine. Cosine, we know, adjacent over hypotenuse. Adjacent over hypotenuse. So we solve for the adjacent of theta, which is negative 6. So cosine of theta is negative 6 over the hypotenuse, which is 10, basically given to us. And that's going to be your answer. The cosine of theta is equal to negative 6 over 10. And that's all.